Hello, my name is Walter Unglaub, and this is Physics Breakthroughs with Atoms. So in the past several decades, there have been a myriad of breakthroughs involving atoms and atomic physics. One such discovery was that of Ununoctium, which is a synthetic element created in a laboratory in Russia in the year 2002, and it's abbreviated UUO, and it has 118 protons. So because this is the heaviest particle that's been discovered, the heaviest atom, it is one of the least stable atoms that's been created, and this is why we don't see much of it in nature. It has to be created using a collider, for example. Another discovery was the experimental realization of what's called a Bose-Einstein Condensate, or BEC for short. And a BEC is a very interesting type of matter in which you trap a bunch of atoms in a potential, let's say an optical potential, and you cool the atoms down to their ground state. So the atoms with greater kinetic energy will fall outside the trap, and whatever's left will be at its ground state. What happens quantum mechanically is that the ground state wave functions start overlapping, so to speak. So you end up with a macroscopic quantum mechanical object, and there's a lot of really interesting physics that one can explore, both experimentally and theoretically. So this was created in a lab in Boulder, Colorado, in the year 1995, and the group won a Nobel Prize in 2001 for the discovery of this theoretical type of matter that Einstein predicted back in the 20s. A third interesting breakthrough, quite recent actually, is one involving cold quantum gases, or CQG for short. And a cold quantum gas is essentially the precursor to a Bose-Einstein condensate before you cool it down to around nanokelvin temperatures, which is very close to absolute zero. And it consists of a collection of gases, and the breakthrough involved sending in light, where a photon here I'm denoting by the Greek letter gamma, and a special experimental setup allowed the experimenters to use these cold atoms in this gas to mediate an interaction between two photons. So you end up with two coupled photons that have properties like a molecule. So this quote-unquote photonic molecule is another recent breakthrough in atomic physics in which we use atoms to cause two photons to have molecular properties, for example. And finally, another breakthrough in physics in the last couple decades involving atoms is that of atomic positioning. So we can use certain probes to move around single atoms, and we can create all sorts of patterns and structures and position individual atoms to our liking so that we can perform experiments or even view different properties of the atoms. My name is Walter Unglaub, and this is Physics Breakthroughs with Atoms.